Hi everyone. So today I wanted to just describe an example that I came across when I was reading this book. It is a very good book on designing data intensive applications. So here in the scalability section, so scalability is the term which describes system's ability to cope with increased load. If we have one user, tomorrow it may be 1,000. Day after tomorrow it may be 1 lakh or million. So systems should be able to handle the load or handle the increasing amount of users. So in the section of describing a load they have provided an example of Twitter. So how Twitter maintains the home timeline. So we will go through what is the example and what is the explanation. So first, what is they have described load. What is a load? So load can be described with a few numbers, which we call load parameters. So the best choice of parameters depend on the architecture of your system. It may be request per second to a web server, that is load for you, or the ratio of read to write in a DB, the number of simultaneously active users in a chat room. So these are some of the parameters. Now they have taken one example, Twitter example. Two of the Twitter's main operations are post tweet and home timeline. So what is a post tweet? A user can publish a new message to their followers, and that is 4.6k request per second on average, and over 12k request per second at peak load. That is a post tweet. Post tweet means there is a write operation in the DB, because whenever you are posting a tweet, so there are two users, one who is creating the tweet. I am creating the tweet, and second, so that will be first write operation, and second part of it is that same tweet should be visible to my followers. So that tweet also should be shown to the home timeline. So that is where it comes. The second part of it, the home timeline. A user can view tweets posted by people they follow, and that is the highest 300k request per second. So I mean that this is the read operation. So it says simply handling 12,000 write per second, peak rate of posting tweet would be fairly easy. However, the scaling challenge is not primarily due to the tweet volume, but due to fan out. Now, what is a fan out? Each user follows many people, and each user is followed by many people. So there are only two ways of implementing these two operations: posting a tweet and viewing a home timeline. Now, what are the two ways in which it can be done? So these are the two ways they have shown. These are the two ways in which this can be done. Simple relational schema for implementing a Twitter home timeline, and this is data pipeline for delivering tweets. So this is a follower ID, this is a followee ID, this is a follow table, this is a tweet table, this is a user table. So ID, followee ID, sender ID, that is the user table. And while trying to understand this, I provided this to a chat GPT, and it explained very beautifully that what does this mean. So let me go to the chat GPT page, and then we will, yes. So as we were discussing, the fan out right path where user is posting a tweet, then system needs to find all followers of that user and insert that new tweet into each follower's home timeline. And second is home timeline read, that is a read path. Now they have taken an example. Let's take an example. User A has a 2 follower and user D has a 10,000 follower. Also, in the extreme cases where there is a million follower or a 20 million, 30 million, and there is a less 1, 2 follower. So let us take this example. So user A is a 2 follower, user B and user C. So user A posts a tweet. System looks up user A's followers, user B and C, and now it will insert the tweet in the timeline cache user B and user C. When user B or user C opens their app, the tweet is instantly visible. Cost is minimal, right? Just to insert, very cheap. When the follower count is less, then the write operation is cheap. Now case 2, when user D has 10,000 followers. Now inserting tweets into the 10,000 timeline cache. There is a very high write cost, but read remains very fast for followers. This is why Twitter refers to this as fan out on write. Now, why this approach? Most of the Twitter traffic is reading timeline. So pre-computing makes this very fast. So it is saying that the number of users who are present on a Twitter. So let's say 10 number of users are total number of users who are present on Twitter. So in the 10 users, there are only 2 users or maximum 3 users who are actually writing, posting a tweet. So 70 to 80 or 95% our users are only reading tweets. They are not actively writing. So in the most of the cases, there is only read operation going. And this caching, it reduces the carry log on the main database. So what are the problems that Twitter faces? The high fan out for celebrities. Now some users have a 30 million plus followers. Writing to all cases at once can be overload. So they have, what is the solution they have done? They have done a use lazy fan out, generating timelines on demand when a follower fetches their feed. So whenever a follower fetches their feed, only then their feed is fetched. So how it works in the backend? Different tables: follows table, tweet table, user timeline, cache list of followers for each user, home timeline API, reads from cache, not from the scratch. So these are the sources we can read from. Again, it has shown that this we are reading from. And again, the key takeaway is writing is expensive, reading is very cheap and fast. So this is a very, I think, good book, and I have started reading it. And as I read more and understand, then I will be sharing. So this book has started with a section of designing the non-functional requirement that we have, like scalability and maintainability and reliability, explaining all this concept. What does this mean? What is the hardware fault? What is the difference between latency and failure? What is a human error? Reliability, scalability. Then there is a, so this is the difference between latency and response time, latency and failure. What is maintainability, operability, simplicity. So these are the things, and this is a new word I heard, evolvability. That system should evolve when the new features, new platforms, new technologies introduced. So that is where this test-driven development or domain-driven design, all that comes. Okay, so that's all. In the next video, maybe I can share the same if I've read more or any other product-related question or anything else. Then that's all. Thank you.